Hey guys, this is the recording for example 3 of section 3.2. Okay, so my daughter Stevie is putting stickers on. Say hi, Stevie.
Hi.
All right, and I'm going to try to record this. Compare the right and left hand derivatives of the function f defined below to show that the function is not differentiable at the point 1, 2. And I'm giving you a piecewise, okay? So let's do the right and left right hand derivative. Let's write the definition first. Limit as h approaches 0 from the right, f of, because I already gave you, let me write the formula first and then I'll plug in what a is. Typically, I'm just gonna straight plug it in for a, but since this is practice and this is notes, I'm just gonna write out everything for us. So f of a is 1 plus h minus f of 1 all over h. As you can see, you already know what f of 1 is. F of 1 is 2. Okay. So limits as h approaches 0 from the right. Here's where I need to plug this in. And this is the part where students are going to be really confused. As h is approaching 0, right, from the right. Now, that means what happens is you need to pick the right piece. Which piece is better for you? Well, this is really the one I'm looking at. Oops, I meant to highlight that. So this is the highlighted part, right? So as h is up, this is a right-hand derivative, okay? A right-hand derivative at the point 1, 2. So I would need to pick that piece right there as my right-hand derivative piece. Ooh, wee. All right, so I'm going to write 2 times 1 plus h minus f of 1 is always known. It's always 2 all over h. Okay, so now I'm just going to slowly simplify that out. Limit as h approaches 0 from the right. That's 2 h2 plus 2h minus 2 all over h. The 2's are going to cancel. I can also cancel out the h. So limit as h approaches 0 from the right is now 2h over h, which is just going to come out to be 2. So that's your right hand derivative. Now I'm going to do the same thing for the left hand derivative. I'm not going to write the formula anymore, but I will start with limits as h approaches 0 from the left of f of h 1 plus h minus f of 1 all over h. Again, this is the left hand derivative, so I'm going to be picking just 2. Okay, so limits as h approaches 0 from the left. What f of h doesn't matter because this is my piece. Doesn't matter what f of what, right? F of 1 plus h, 2 plus h, whatever it is. Doesn't matter what x location is. This piece right here, it's always going to give me an output of 2. So that's 2, okay? So that's 2 minus this piece right here will never ever change. That piece right here will always be 2. So 2 minus 2 all over h. So that's 0 over h, which is really 0. Okay. So as you can see, the right-hand derivative and the left-hand derivative are different. So what does that mean? Since the left and right has finite, that means it actually has an answer, right? Finite limits. And oops, and not equal. This, based on our definition, this is a corner. This is a corner. So what does that mean? That means it's not differentiable at x equals to 1 because it is a corner. And how do you know a corner? A corner is when you do have a limit when you do the right hand derivative, and when you do have a limit when you do the left hand derivative, they're just not the same slope. And this is the end of this recording.